Hi there, welcome back to the channel. Welcome to the third and final video in the restoration of this Grundig 2447. This is the one that's got two cousins that are very, very similar in style to it. And she presented quite a few interesting challenges, like a tuning condenser that had been ripped out and tuning dial missing and things like that. And all those things, although they might sound quite, quite bad, they actually make the project a lot more interesting. I'm a sucker for punishment, but I do enjoy tackling things I've not done before or haven't had a lot of experience with, because that's the only way you learn. And in this video, I'll show you some of the tricks that I applied here. There are a few little sneaky ones that I've learned from other creators and other restorers, and I hope that by showing you how I did them, you might be able to implement them into your restorations and make the hobby a lot more interesting and a lot more productive. So if you enjoy this sort of thing, stick around, enjoy the video. Let me show you a few tricks related to the dial string, dial cords, and the pointer. There were a few issues with this radio. It had no dial strings, and one of the pointers had disappeared. So let me go one step at a time. First of all, the dial pointer. It had one, which is that guy over there. So I designed exactly the same as that one. I figured out the size of this thing. This one had to be just a little bit longer than that one. And I copied that one exactly into a Fusion drawing and reproduced it. And I tell you what, this thing came out absolutely perfectly. Now, mind you, it's not transparent, as you can tell, but it's got all the little dents, every detail that's on that one is on here, including sort of a ridge that was cut in there, in which I have painted the pointer itself, and this will now fit on there perfectly. And it's done something like, let me try and do it now. It goes down and then it goes up. This is always a little bit tricky, but you can get it. It's like that. And then that part there actually fits onto this fishing line that holds it in place, but I'll worry about that later. What I'm going to show you now is how I do the tying of the spring, or the two ends together. Let's put this aside for now. And the one thing that I want to show you is how I use these little rivets. It's a little brass rivet. I think it's like 2 millimeters by 4. I buy these in little packets. They come in, I think it's 10 per box or 10 per packet. And I'm going to show you how I tie this up. And then I also want to show you a knot that I've learned to put on this side, which allows you to adjust it. Now, this is always a problem. If you use dial cord that's not pre-stressed or pre-tensioned, would that be tensioned? Tensioned? This thing can actually stretch, which means that if you set the dial cord perfectly with a spring, at some point in time, you may get to the point where you need to tighten it. And if you've got knots on there, or even if you've got rivets on both sides, you can't really tighten it. Well, I've discovered a knot. It's a slipping knot. Most of you, or many of you, probably know it. I didn't. And it's a lifesaver for me. I'm going to link the video below where I got this from, so you can see it in better detail than I'll be able to show you, because this is very, very thin cord here. They do it with a rope, but it works magically. You tie a particular type of knot, which allows you then to tighten it. And in other words, stretch the spring more if the tension requires adjustment. But first of all, I'm going to do this side. And what I do here is I set this to about, well, I know this is at the end. This is at the absolute end now. And I know that the FM is also at the absolute end. Make sure it is. Yeah. So I'm going to tie the spring on here. What I want really is to tie the spring like about there, okay? So it's off the edge of where the dial pointer would be. So I want to tie it about there, but how do I tie it easily? Well, let me show you. I've made a mark where I can see where the joint is. I join these two together, pinch them together, and I've got to get them through this. There we go. Now I just feed this in here. Come on, boy. Come on, boy. Oh, God. There we go, like that. Bring this up. This is where I want it. It's about, let's call it there. And I'm going to do it like, leave that much space. I think you can see it. Now I just take the pliers. These are round-nosed, and I'm going to pinch it. And you know what? This thing ain't going nowhere. In fact, I can do it with the other pliers and just flatten it a bit more. So now this thing is tight, okay? So I've got one side done. Just trim this about there. That side is done. Now I need to get this guy through here. And I need to tie it like that, but I need to tension it, okay? And what's more, I want to be able to adjust the tension. So what I'm going to do is I'll probably have to do it off camera. I don't think I'll be able to do it with a camera showing on here. Well, maybe I can, but I will link the video, or put a link in the description below to the video where they describe this slipping knot perfectly. Let's see if I can do this. So you go around once, you go around once like that, you go around twice like that, get it as close as you can so you don't have too much of a gap on this end, twice through the inside, and then once around the outside, like that, and then you pass this guy through there, and you tighten it up and you neaten it up. Now that is very tight. I can't pull it, but I need more tension on here. So what I do is I go to one of these, and I think it's that one. I hold it and I pull this. See that? Now this will not go in. It goes one way, but it won't go back. In fact, this thing is tightening it more and more until I touch the middle one. But if I do that, make sure that is tight. Okay? I've just tightened that. I've just tensioned that. And let's put this on AM. Oh, I put blue tack on the edges, on the ends here, so this wouldn't move. And I was forgetting to remove the blue tack. Perfect. See that? Right, so if I want to tighten this a bit more, I just come here, I grab one of them. If I grab the other one and pull, nothing happens. But if I grab this one and pull, I can just tighten it. Okay? And you've got to be careful where you put this. You can't put it too close to that edge, otherwise you don't have this length to be able to tighten it. Now I've done the same for the bottom one there, and that's working perfectly as well. See? Now what I'm going to do is I'm going to loosen this a bit, and I can loosen it if I go to the inner one, loosen it as in release the tension, because I want to put the pointer in place. And that's just a matter of getting this to the end. I think it's the same as the one below. I think it's going to be in more or less the same place. I can adjust it later. And I've got to put this in like this. It goes down, then it goes up. Oh, this is so difficult to do it when you're trying to film it at the same time. There we go. And now I've got to get this whole contraption through a funny gap that this thing has got on the side. Oh, it slipped at the top. Damn it. Oh, maybe it is easier to do it like this. Oh, yeah, it's done. There we go. And of course, I can then adjust this because I can just grab it carefully and push it one way or the other to make sure that it's perfectly aligned to the ends. So look at the video link below to see how this knot works. This magical knot. This thing's going to save me a lot of headaches because I've had so much trouble in the past trying to tighten these guys. Wrong one. As I said, only one of them allows you to move. The other one is perfectly tight. And it should hold like that. Right, that's the first trick. Brass rivets for one end. Mind you, you could do the same thing there. You know, you could literally just put a brass rivet in there, tighten it and squeeze it together. But that means that you couldn't then adjust it in the future if you needed to. And I'm confident enough to clip that off. The other thing you can do is that last knot that you have here, you can make it a lasso thing where you can just pull it out and the whole thing comes out and loosens up again. As I said, look at the video in the linked below. Right, that's the first one. The second thing I want to show you is how I fitted this tuning condenser. I made a hole in the actual condenser enclosure to get this screw in. I put a couple of spaces there that I still needed to put in because I needed this thing to shift forward slightly. You'll see why in a second. I have got, this is actually a 10 nanofarad capacitor, ceramic. The one I used in the experiment that I showed you was not suitable, as somebody mentioned in the comments. That really was not suitable for RF. It's for AF, and even then it's a pretty piss poor capacitor. These ceramics, you can still get better ones. You can get the zero coefficient. The ones that do not change at all with temperature. This is not as good, but it's good enough. And I put that in there and then tied connected it to the switch with that one in series with that condenser. Now, just one thing I want to mention. Somebody mentioned that this thing will affect linearity. Yes, it will, as I said in the last video. This will affect linearity of the scale. That's inevitable. And he suggested something which was actually very, very clever. Instead of putting a capacitor in series to reduce the value, I could just pull out these plates. In other words, bend these out. And these are used to adjust linearity, precisely to adjust linearity. But if you move them out far enough, you're reducing the capacitance. And if you move all of them out, you're reducing the entire range of the capacitance. You can do it on this side, and you can do it on that side. Now bear in mind, the back one is the only one that I want to adjust, okay? Now I tried that. I tried to bend these out as much as was practical without it touching the sides. And the difference or the drop in capacitance was very, very small. It was like, what was it? I think probably about 5 picofarads. So it still was not enough. And I decided to put them back and just settle for having that one in series. I'm happy with that. I know the linearity is not going to be good, but hey, trying to find a station on shortwave on this thing anyway is going to be a challenge, although we do have a particular band, the 49 meter band. So accuracy of the dial is not something I'm particularly interested in, especially with the way the shortwave is lined up in front there. Right, that's the first thing. Let's look at the front. On the front, I had to deal with the issue of this thing was actually raising up. It was flipping up because the back was not keeping it pushed down. So I needed something to push this down, and I decided to design and 3D print a little bracket. Let me show you on the screen what that looks like. This bracket just goes around the spindle there, the fixed part of the spindle, so it doesn't affect the actual turning, and it bolts then to this negative that was already on this faceplate here. I thought of drilling through it, but this is really steel, very difficult to drill through that. So I just put a nut and bolt with some of those washers. This ain't going on anywhere. It's really firm. This thing is completely solid and sturdy. So that is perfect. That's working very, very well. And that was the final adjustment, or the final corrections that I needed to make on the tuning condenser to fit it in place and have it as a permanent fixture. It looks almost like it belongs here. I mean, there are a few things that you can see were tampered with. I'm hoping that whoever sees this 50 years from now will realize that it was tampered with carefully and with some thought, and hopefully they'll test it out before they start stripping this thing apart. Okay, that's issue number 2. Issue number 3 is something that's very, very difficult for me to show you on here, but what it is this clutch. Now this clutch mechanism changes from, I don't even know if you can see that. Yeah, you can. AM tuning to FM tuning. So depending on whether you select one of the AM bands or FM, it changes that. The clutch grips a different spindle and it'll then tune whether you tune AM or FM, right? The problem here, and it happens with a lot of these radios that have this clutch mechanism, is that one side usually starts slipping. And yes, it's usually the FM that starts slipping, probably because it's used most. But it's got a serrated edge on the inside, and that loses traction. So the trick to sort that out is to improve the resistance, the traction on there, the grip, if you want to call it that. And one way to do it, you could dismantle the whole thing, but one way to do it is to take this sandpaper that has that self-stick pad on the back, or the felt on the back that's used on those sanders that have a sort of a Velcro type layer at the bottom, and you cut a circle on there, the size of that thing, make a hole through it and push it in and leave it in place, because then it's going to grab properly. Now, again, I'm shamelessly stealing ideas from other people. This is from a particularly good friend of mine on the channel, Derek Herbst, and I'm going to link the video where he shows that in detail. I'll link that below so you can see where the idea came from and where I copied it from. So that was issue number 3 solved. Now we've got a main one, which is dealing with the RF alignment of the AM bands because of the capacitor that I've changed. I have to check the oscillator section, which I think will be pretty close because that capacitor was practically the value listed on the schematic, but the front end one was not. And as I mentioned in the previous video, the Shortwave was particularly deaf. I could pick up, but it was fairly deaf, and I think it's because the front end was completely out of alignment. I've got the alignment instructions, so I'm going to go and do that next. Okay, I'm going to do an RF alignment. I expect that it's probably going to be necessary. I'm not sure that the oscillator will be far out because the section of the tuning condenser that I replaced in there, the 501 picofarads, was pretty close to the 505 they mentioned, but obviously there could be differences, so we're going to do that as well. So this is obviously just for the AM bands. I'm not touching the FM. It is fantastic. So that part of it is staying as it is. Now, the other thing I want to tell you is that I've checked the IF very quickly. There's nothing wrong with it. There was no need to change anything, to adjust anything. I made a few twirls on there, but it made really no difference. So the IF alignment was not necessary. And if you want to see how that is done, go to the Back to Basics series. Have fun. It's all there in great detail, probably too much detail. But anyway, the first thing I did here was I made sure that the pointers were aligned to the end. There's a marker there. If you look at this end here, there's a little dot over there and a dot down here. That's where your pointer's got to point when this is on the absolute left-hand side. I've also noticed that this particular marker, the pointer, should have been a bit higher because it's not being seen on the long wave scale. I'll probably print another one a little bit taller. Okay, now the FM one I had already adjusted. I didn't make any adjustments other than aligning it to the pointer over there. And I'm not going to touch the FM because, as I said, the FM sounds absolutely fantastic. I'm sure that if I mess with it, it'll make it worse. And that's something you've got to accept sometimes. You know, you might be all enthusiastic about trying all these alignments, but believe me, if something is good, leave it. Leave it. It is so easy to make things worse, you won't believe. So back to here, we'll start on the medium wave. Put it on medium wave. Let me just go and look at the instructions and see what they say. Here's the description of the 460 kilohertz IF alignment. I'm not touching that. If we go down here, we've got the medium wave or AM oscillator and front end. Oscillator and front end. Now, they start with medium wave. They say set it on 560 kilohertz, adjust 1 for maximum, and that's the oscillator, 4 for maximum, and that's the front end circuit. Now, this row or this column here is the one I suspect is going to be the one we're going to see quite a few differences on all the bands. That's what I expect. Now, I'm going to check the oscillator anyway, because there probably will be slight changes. So 560 we adjust 1, and then we set it to 1450 and we adjust 2. Now this is a signal that we're going to pump in at the antenna, and it's going to come from my signal generator with a modulated tone on there, and I'm going to pass it through my attenuator, which I've been using, and it works very well. I'm not worried about the sensitivities and the width and the breadth and all that stuff. I'm doing the simplest version possible. So let's get started. Where is 1, 2, 3, 4, 5, 6, 7, 8? Those are the numbers we're looking for. And if we go down here, that is pertinent to the IF alignment. And this section here is what we're really interested in. We're talking about 1, 2, 3, 4, 5, 6, 7, 8. So there's 1, there's 2, 3, 4. Where is 5? 5, 6, 7, and 8. One more thing. These coils, or this one and that one, on that ferrite antenna are still completely sealed with wax. I'm not going to touch them either. If you can remove them. Usually they're loose. If they're loose, you just move it backwards and forwards. You don't touch it because that will affect the tuning. So those again are probably in the perfect positions to give us a good result. But here are the numbers, and it's on the underside. We'll see that in a second. One other thing, I'm going to adjust the oscillator first. So I'm going to do 1 and 2 first by jumping from 560 to 1450, and then I'll come and look at the front end, even though that's the most important for me. So 1 and 2, let's have a look at where they are. 1 and 2, so it's those two there. That's a coil, and that's a trimmer capacitor. Those are the two I'm interested in. 1 is on 560, and 2 is on 1450. So let's set that up. So we'll set the frequency at 560 kilohertz. It's modulated with a tone, and the amplitude, let's put that at a minimum. That's as low as this will go, and I'm going to switch it on, and it's going to my little switched attenuator. I'm not sure how much attenuation I'll need. This is the one I did the project on recently, and it works beautifully. Let's leave it at 0 dB attenuation, because I'm not actually feeding this into the antenna. Let me show you what I'm doing here. I'm actually feeding it into this coil. This is just a coil. I 3D printed a former for it, and the signal is going in there, so it's being radiated in the same axis as the ferrite antenna that's at the top there. I find that with medium wave and long wave, this works very, very well. And I can now switch on the radio. I've got it on medium wave, and I'm going to see where the signal is. We're looking for it at 560 kilohertz. And I'm just going to do it by ear. I'm listening for the peak. That is peaked. That was easy. So we'll change this to 1450. Put it on. Now 1450 is, there's a marker, there's a little blip over there. That's where I expect to see it, exactly where the screwdriver is. There. It's a little bit out, so I want it there. There exactly. And we need to adjust 2. And 2 is that cap over there. And I don't have a tool for this, but this is grounded, so you should not do this with your fingers. We find it and chase it. I'm turning the knob progressively closer to where I want it. It's just off. The volume up a bit. I think that's probably there. Just a little bit more. That is now spot on, and I can do the final adjustment. Okay, that's done. Now what I need to do is I need to redo both of those. Check 560, check 1450, make sure that those are correct. Let me do that and get back to you. Now on the 560, the adjustment I need to make is on the ferrite antenna, which as I said, I'm not going to touch. And on the 1450, which I'm dialing in now, I need to adjust number 3, which is that guy over there. So let's go to 1450. It's noticeably weaker, this signal. And we'll watch the meter, and I'll be adjusting that guy over there, okay? Now to make this adjustment, I'm using the Simpson. I've connected the Simpson on AC volts across the speaker, and I don't see much because this is a very low voltage, so I've got the multiplier here. And that's not enough. I'm going to multiply by 10 instead of by 5. It's still not much, but if I give more volume, it's on peak volume, but I can see it there, and I'm going to put this on dummy load so we don't have to listen to it. And we're going to watch the meter while I adjust this. Okay, here goes. Well, that's not too dramatic, is it? Bloody hell, that's nothing. I see almost no change. I see no change. So, yeah, I guess not much change there, is there? That's a pity. I was actually expecting some improvement. Oh well, it is what it is. It is what it is. It seems that tuning condenser was probably pretty close because I don't see any difference. All right, well, let's move on to the long wave. So long wave, we'll set it to long wave, and they tell us at 160 kilohertz, 3. Oh, I made a mistake. That was supposed to be 5. I read 3. My bad. I'm going to go back and adjust that one. No wonder we got no difference. Idiot. Okay, go back. And 5 is that capacitor over there. Okay, good. Let's try that. So that capacitor over there, make sure we've still got a signal. I must go to medium wave, 1450, and that capacitor over there. So let's try that. Ah. Beauty. Whoa. That's making a hell of a difference. I've just lowered the volume. I want to see if I get a peak, and then that's the peak. That is a peak. That did amazingly. That did amazingly. Okay, now I feel better. Now I feel much better. All right, so back to the long wave. And long wave, it's 3, that guy there. And we tune it to 160 kilohertz. And it's 3 and 6. Now 6 again is on the 6 again is that coil on the ferrite, which I'm not going to change. It was picking up very well when I can pick something up on long wave, so I'm not going to change that. So I'm going to just check the oscillator. So we'll set that guy to 160 kilohertz. We'll select long wave, put the tone on, and tune to 160. Now 160 is that little blip over there. See if it's anywhere near there. Is that right? Long wave? Whoa, it's way out. Look at where it is. So we need to bring it up to there. This is way out. Okay, so we are talking about number 3, the one that I got wrong. So let's do that. So I want to change that guy. No wonder it's out, I messed with it. It was probably perfect. I'm just tuning at the top closer to the 150, or rather 160. That's exactly on 160 now. Whoa. There we go, it's on 160. Perfect. Put the sound off. And that's the only change I'm going to make on long wave. There's no other adjustment other than the ferrite one, which I don't want to touch. And now we get to shortwave. And on shortwave, again, there's only one adjustment on the dial, 6.1 megahertz. So we've got to go to shortwave, select shortwave, and there's one adjustment only, 6.1 megahertz, and we adjust 7, which is the oscillator, and 8, which is the front end. And here it is. That bottom coil, 7 is the oscillator, and that one there, 8 is the front end. So we will do that. Set this to 6.1 megahertz. I'm not sure what attenuation I need. I now need to put in the dummy antenna, which I've just clicked on. And I need to connect the antenna to the actual antenna as opposed to connecting it to the ferrite radiator, that coil. So I've got that done. Put the sound on. And 6.1 is, there's 6.2, 6.16, 6.07. It's that little blip over there. See if it's anywhere near there. I can hear it here. It's quite far off. It's at 6.12. I want it over there. So I'm going to adjust it from there to there. Okay? And that is 7 over here. Make sure I'm adjusting it correctly. Is this thing even connected? Just want to check that the antenna is connected. Oh, I put it on the FM antenna by mistake. My bad. Let's try again. Okay, it's even further off than I thought. I'm going to start adjusting this guy. I'm doing a bit here and a bit on the dial, moving it closer to 6.1. The dial is now perfectly on 6.1, and now I'm going to peak it. Put the volume down. That is peaked. Okay. Now I need to look at the, I need to adjust that guy for the strength, for the front end, but we need to look at the meter. So while I adjust that, you look at the meter, see what we get. Oh, that's going up nicely. Let me attenuate the signal a bit more. 9 dBs. Oh, that is a lot. Of attenuating another, up to 21 dB attenuation on the attenuator. There's our peak. That's our peak. Now that made a hell of a difference. Turn off. That made a hell of a difference because, as I said, it did seem like the shortwave was deaf. Certainly was. So on the shortwave, this made a huge difference. We should be able to hear that now. It's early evening, so let's try and see what we can pick up now. Now, instead of the signal generator, I'm going to take the signal from the mini whip antenna, also on the undershelf module. That's going straight into the antenna input. And I'm going to whoa. Put the sound on. That is shortwave, 49 meter band. Okay, it is still early, but we are picking it up. Try medium wave. Canary Islands.
El fundador, el padre de la ultraderecha actual de Francia, que nunca gobernó, pero sí mandó. París, Antonio Delgado y mucho. Partido Agrupación Nacional, el hombre que introdujo la crítica.
Pretty good. These are all from the Canary Islands. They've got a lot of medium wave down there. That's our local station, our single local AM band. That is from North Africa. So yeah, that's working well. Let's try long wave. Not much wrong here, but we should pick up at least one. There we go. Maybe another one. This is strange. This is at 200 or 198. This sounds like BBC Radio 4. Now, I thought that they had switched that off. Listen to that.
C'est une tête très pragmatique et très cartésienne. Exactement. Okay.
Brilliant. Okay, I'm asking some of the Brits. This thing is on, this was picking up an English station on 200 kilohertz, which is damn close to 198. Now, I know the BBC Radio 4, I think it was Radio 4, was on 198 from the south of England. And my understanding was they'd stopped transmitting. So unless we're hearing sounds from the past, they're back online. If you know anything about that, drop me a comment. I'm very curious to know. But that's the result. That's it. We've done the RF alignment. We've done the fixing of the tuning condenser. We've what else have we done? We've built that up. I've got to make this just a little bit longer. I'm going to reprint that. This is still loose. This actually fixes to the front of the cabinet. I just put this on here so we can get the markings. I've shown you my little trick with the adjustable knots on there. So now it's just a question of what am I going to do next? I think I'm just going to check the voltage again because all the tubes are now in. I'm going to check the B+, make an adjustment there like I did before on that little adjustable MOSFET dropper on the side. And then this thing is ready to go into the cabinet and I can give you a final demo. Unless I find something else in the meantime. Oh, by the way, I did change that light bulb to a LED and I put a 330 ohm resistor in series with the LED and I put another diode, a 1N4148, in reverse to the LED so it doesn't get burnt out with high voltage. I know this is yellow, this is white. I was going to do the same for that one, but I just couldn't get myself to blow up or break a perfectly good light bulb to create my LED version. So it's going to be sort of yellow and white when this thing burns out, if it burns out, or if I get another one exactly like this that's burnt out, I'll just replace it with another LED version. Yeah, okay, this is looking good. All right, I'm going to adjust the B+. I think it might need just a small adjustment because now that I've got all the tubes in, it's drawing more current. So obviously it'll drop the voltage. Now it's on medium wave, and according to them, on medium wave, this should be at 282. So I'm going to just tweak it up a little bit. It's as easy as that. 282. Good. And according to the schematic, the B2 Plus should be at 245. It's at 243. That's perfectly good enough for me. So that's the final adjustment on here. I think this is all done and I'm going to put it into the cabinet. And here she is, folks. She's come out absolutely beautifully, beautifully. And FM, which I can't play music on, is really, really good. You go to the other strong station here.
As equipas de investigadores para saber o que é que interessa mais. O que é que mais, se calhar os sponsors também aceitam.
Can't play music, but you get the picture.
E também isto vai dar um alerta para os melhores do mundo,
Se
para as
concentrarem.
equipas, sim, mas as equipas principais estavam lá. Agora estamos a dar diretivas para o resto do mundo, não só.
So I'm really pleased with the result, and it looks absolutely fabulous. One thing I did change is I changed these 3 screws down here. There are 3 little screws that hold the faceplate on. There were only 2. This one was missing. So I found 3 brass ones that are identical and of the same size, and I think they fit beautifully on here. The cabinet is immaculate. Both front, side, back, you name it. This thing looks like it's just come out of the factory. So again, this is a worthy member of the family going to join the 2 cousins that I've already got. And I must say, I really love these guys. And it's not the sort of radio that I'll be that keen to put Bluetooth in, because the speaker is not that fabulous. It's a smallish speaker. You know, if you want to listen to Bluetooth on tube radios, which I'm a great supporter of, and I do it on most of my tube radios, the bigger ones are the ones to go for, because the sound systems are more dramatic and the result ends up being a lot more satisfying. But I mean, visually, this thing is fantastic. I love it. And I hope you do too. And I hope you've enjoyed the series. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Links are in the description below. So once again, I want to thank you for watching. Bye for now. And most of all, stay safe.